Geometry 4-4, proving triangles congruent. Proving triangles congruent using side, 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 and side angle side. So we're going to look at side, side, side first. And we have this postulate. And in our book it's called 4.1. Don't worry about that. I don't care about the number. What I do care about is side, side, side. Or SSS congruence. Now what this postulate says is that if I have two triangles, let's just draw two triangles. And this is triangle ABC, and this is triangle DEF. If I have AB congruent to DE and EF congruent to BC and CA congruent to FD, if the three sides are congruent, then the triangles are congruent. So if we know that the sides are all congruent, the corresponding sides are congruent, then we also know that the angles are going to be congruent as well, so the triangles are congruent. Let's do an example. Given, oh, not a proof, Mr. V. Segment GH is congruent to segment KJ. Segment HL is congruent to segment JL. And L is the midpoint of GK. Segment GK. And then we want to prove triangle GHL is congruent to triangle KJL. So let's draw the triangles. Right, so we got these two triangles here, and down here on the left is G, up on the top is H, next to H is J, down over here on the right is K, and then the middle is L. And so L is the midpoint of GK. So we know that information. L is the midpoint of GK, which means that since this is the midpoint, that JL and LK are congruent because L is right in between them. It cuts it in half, cuts the segment in half. GH is congruent to KJ, and HL is congruent to JL. So I've got two corresponding sides, or two sets of corresponding sides that are congruent. I just have to prove that these sides down here at the bottom are congruent. And the way I'm going to do that is I'm going to say, look, L is the midpoint, so these two segments are congruent. So this is a fairly simple proof. Statements and reasons. Now, I'm not going to write all of this down, even though I should, in the statements section. And the reason that these are okay to put here is because it's the given. Now, I'm just going to say segment GL is congruent to segment LK and that is because of the midpoint theorem, or definition of midpoint. Definition of midpoint might, well, okay, we'll keep going. Now, since I have these two segments congruent, and these are congruent, and these are congruent, then I can just say these triangles are congruent. Triangle GHL is congruent to triangle KJL. KJL. And that is because all of their sides are congruent, so side, side, side. Now we're going to look at side angle side. 4.2, side angle side. And we can abbreviate that SAS, congruence. So let's draw two triangles. Triangle ABC and triangle DEF. I'm going to have AB is congruent to DE, and angle B is congruent to angle E, and BC is congruent to FE. Or EF, I should say, probably. And what we're doing here, notice how I have a side and an angle and a side. Side, angle, side. Side, angle, side. I have two angles, two sides, and the angle that is contained between those two sides, or is included with these two sides, is the angle that we're going to be talking about in this postulate, side, angle, side. So if two sides and the included angle are congruent, then the triangles are congruent. So let's look at these triangles again real quick. If I have side, side, angle, then that's not the same as side, angle, side. So if this angle is over here, if this is the one that's congruent, C or F, and not B or E, then we don't have side, angle, side. We have side, side, angle, or angle, side, side, for those of you who want to be more crass about it. Either way, that one doesn't work, because there are two different side lengths that you can get for AC if we don't know this angle here, because this can swing this way or it could swing this way. So so we can't prove by side, side, angle that two triangles are congruent, but we can prove that side, angle, side, they are. So let's do a proof, and then we'll be done with 4-4. Here's the example. Given BC is congruent to DC, angle BCF is congruent to angle ECD, and FC is congruent to EC. Prove angle CFD is congruent to angle CEB. So we're not proving two triangles are congruent. We're going to do that as part of this proof, but we're being asked to prove that these two angles are congruent. So that's a little bit different than what we've been doing. So I've got this triangle shape, and then I've got another triangle kind of inside of it like that. That should be a straight line. All right, so I've got B up here, and then F, and then E, and then D. Down at the bottom I have C. Okay, so I've got BC, segment BC and segment DC are congruent. BC and DC, those are congruent. And then BCF is congruent to ECD, so those two angles are congruent. And then FC, segment FC and segment EC are congruent. Okay, so let's get our proof started here. Statements and reasons. Hopefully this is enough room down here. So let's come up with a plan first here. So we're going to take all of the given, we're going to put that right there, and that's going to be given. All right, but let's look at this, what we have. We have this side congruent to this side, we have this angle congruent to this angle, and this side congruent to this side. And so we have side, angle, side. Side, angle, side. So we have the two sides are congruent, and the included angle is congruent. So we can prove that BCF and triangle BCF and triangle DCE are congruent triangles. So if we do that, then we can say that CFD and CEB are congruent, or can we? We can. So here's how we're going to do this. We're trying to find that CFD, we're trying to find that this angle here is congruent to CEB, this angle here. We're trying to prove that those two angles are congruent. Now, if I know that these two triangles are congruent, then I know that this angle is going to be congruent to this angle. And if I know that, then if I know that this angle is congruent to this angle, then I also know that this angle is congruent to this angle, because each of these, if you subtract 180 degrees from it, you get that one. So if I have this angle, say it's 120 degrees, I subtract that from 180, this will be 60. If this is 120 degrees, I subtract that from 180, this will be 60. And so I know that if these two triangles are congruent, that means these two angles are congruent, which means that these two angles are going to need to be congruent too, because both of these form a linear pair. Okay, so I've got this given. I've got angle, side, angle. So I can say already that triangle BCF is congruent to triangle DCE. And that's by angle, oops, not angle, side, angle, side. Side, angle, side, side, angle, side. Okay, now I'm going to say that angle, this angle in here, BFC is congruent to this angle DEC. And this is by a reason that is called, that is important. That's one that you might need to know. CPCTC. And this is an abbreviation for corresponding parts of congruent triangles are congruent. That just means if these two triangles are congruent, that means all of their parts are also congruent, all the corresponding parts. So we know now, we have proven that BFC and DEC, those two angles are congruent. Now, we're going to say that angle CFD is congruent to angle CEB by supplementary angles. We know that these are supplementary angles, and so they are congruent to one another. This is maybe a step or two skipped, but I would definitely accept this on a test. All right, so that is 4-4. Do your homework.